Hi, this video is about how to use stack by using push and pop instructions. So I'm going to show you a sample program that will use push and pop, example of how to use push and pop, and to also give you an idea of how stack works. Paano ba talaga nagwo-work ang stack? Okay, so first is, let's see, I am going to copy and paste this program that I have created. We'll run this first and I'm going to discuss it. Oh, it's already here. I just want to make sure. Okay, so I'll run this just to show you what the program does, and then I'll discuss the program line by line. So here is the program. I'm going to 1 2 3 4 5 6 7 8 9. Uy, there. Oops, wait, it's supposed to display. There's something is wrong with the program. I'll fix it. I'll no longer record it again. I'll just fix it here. I did not call next line. I should have next line here. Okay, let's do it again. So 1 2 3 4 5 6 7 8 9, A B C D E F G. Okay, so the program, what the program does is I typed some characters, and then the output is the reverse of that what I have typed. So this is an example of how you can use the stack. We know that if you use the stack, it's first in, last out. So in the example here, the first in is 1, so it becomes the last to come out. Last in is H. This is the last character that I have typed, and it was the first to come out. Okay, now let's look at the program. How did I made use of the stack to come up with this output? So main, sorry, I did no longer use the what do you put here? I forgot. Oh, org 100, since I don't need to jump main because I am not going to define anything. So I did not define any string or any other thing. So it did not include that, but it has to be included so that you just have to get used. Anyway, so this is the main program. So this one is to input character, one character, keyboard input with display. So interrupt 2101, and the keyboard that you have pressed is save on AL. So I compare that AL if it's an enter key. 0D is this is the ASCII for enter key. And then if it's equal enter key, it means that I have to exit. So exit is here. We'll look at it in a while. So if it's not an enter key, I did not press enter yet, I was still typing any character, then and it will push AX. When I push AX, basically I'm saving AX to the stack. So I push AX. Why not just push AL? Because AL is the one that contains the character that I have pressed. You cannot push 8 bits in a stack. It has to be 16-bit. That's why I have to push the whole AX, not just AL. Even though I'm only saving the AL, I have to push the whole AX. So when you push this one, you are saving AX. saving content of AX into the stack there. And then, so every time I push something on the stack, I use a counter, which is the CX. So I use CX as my counter, and then go back again. We'll wait again for input. So this program will only exit, will only stop if I use my enter key, which is 0D. So if I did not press enter key, then it will go on, and then it will push and push and push all the characters on the stack. Okay, assuming I already entered, I press enter key because I already want to stop. So it will have to jump to exit. So exit is loop here. There's supposed to be one more instruction here. Call next line. So call next line, so that we will just know that the output will be in the next line. That's why we call the next line here. And then I pop the AX. So I get the AX, the data. I'm going to remove the data from the stack. This is the pop. This is the push. This one is when I'm using the stack, I'm going to save data on the stack. This one, I'm going to remove data from the stack. So again, I pop the AX, and then I displayed it. Actually, there's a shortcut here. Instead of DX, instead of popping it and place it in AX, I just pop DX, so that I can already remove this part. So I pop DX, and then I would like to display the string which is contained in DX interrupt 21, then loop here. The loop here is, since my counter is in CX, since I've been adding 1 to CX, so my CX now became my counter. It becomes my counter. So every time I push something in the stack, CX is incremented. So it becomes my counter. So when I loop it here, all it does is decrease. The loop will start once the CX becomes 0. Since there is no other program here in between, so I am guaranteed that the value of CX is what is the final value here. I always add 1 just to make sure that the CX, supposedly I should have placed something else here. Then never mind. So anyway, the only thing that I have changed here is this one. Instead of having this, and this one is pop AX, I automatically popped or get the data and put it in DX right away, instead of putting it in AX and move AL to DL. So I remove one line. Let's see if this one will work. I'll just change it there instead of copy paste. So in our emulator, let's see if I'm going to change this. Where is that? This one, pop. I'll go pop DX, and then I'm going to remove this. So it should still work, same thing. There, see? So that's how push and pop work. So you can push any of the register, 16-bit register, and you can pop it also in any of the register where you want to save the data that you are getting from the stack. So when you push, you save the data in the stack, okay? And when you pop, you're getting data on the stack. I hope this is something that you have understand. Anyway, if ever you have some clarification, you can drop me a line in our GC, or we can discuss it during our during our session on Friday. Thank you for listening.